Hello, this video is about chapter 20, influence on two population proportions, or influence on comparing two population proportions. First of all, we give a motivating example. So this example is taken from a textbook. Researchers randomly divided 4,532 healthy women over the age of 65 into two groups. One group consisting of 2,229 women received hormone replacement therapy. The other group consisting of 2,303 women received placebo. Over 5 years, 40 of the women receiving the therapy were diagnosed with dementia, compared with 21 of those getting placebo. So the question is, do the data provide sufficient evidence to conclude that healthy women over 65 years old who take hormone replacement therapy are at greater risk for dementia than those who do not? So this is question one. So question one is concerned with testing hypothesis. So we're going to follow the 4 standard steps in setting up hypothesis. And question 2, we need to determine a 95% confidence interval for the difference in dementia risk rates for those women who take hormone replacement therapy and those who do not. So we're going to show standard procedure for tackling the two problems. So first of all, we're going to talk about the general procedure of testing two proportions. Okay, the test procedure has 4 steps. Here we talk about a general procedure. Then we will talk about the example particularly. The step 1 is to set up a null hypothesis and alternative hypothesis. So here, because we are comparing two proportions, so we need to use P1 and P2 representing the population proportions. The alternative hypothesis can be P1 less than P2, or P1 is greater than P2, or P1 is not equal to P2, depending upon the researcher's hypothesis. So actually, for our example, if P1 represents the risk of using hormone replacement therapy, then we need to test that P1 is greater than P2. Here, P2 represents the risk for those who do not use hormone replacement therapy. We expect the risk to be smaller. So that's why we test P1 is greater than P2 for HA. Okay. Step 2, we're going to use a standard normal test statistic. So the statistic is denoted as Z. Z equals the numerator P1 hat minus P2 hat. Denominator is the standard error, square root of P hat times 1 minus P hat divided by N1. plus p hat times 1 minus p hat divided by n2. So here n1 is the sample size of the first sample. N2 is the sample size of the second sample. And p1 hat is called the first sample proportion because you have two samples. So based on each sample, you can calculate p1 hat and p2 hat. So the calculation is the same as before. So here p1 hat is equal to x1 divided by n1. n1 is the sample size of the first sample. x1 is the number of successes in the first sample. And similarly, p2 hat is equal to x2 over n2. And p hat, here called pooled sample proportion, is equal to the combined number of successes divided by the total sample size from the two samples. So the numerator is x1 plus x2. The denominator is n1 plus n2. All right. So step 3 is the calculation of p-value. So the p-value is based on the standard normal distribution. So we draw a standard normal curve and we label the statistic value z. And the p-value really depends upon whether HA involve less than sign, greater than sign, or not equal sign. So if HA takes the form that P1 is less than P2, the p-value will be the left area to the value of z. If HA takes the form that P1 is greater than P2, then the p-value is the right tail area. If HA takes the form that P1 is not equal to P2, the p-value will be twice the smaller region as before. All right, now we can talk about our example. Okay, so here we are working on the examples. So we first define P1 to be the risk of using hormone replacement therapy. P2 represents the risk of not using the therapy or risk of the control. In step 1, we set up a null and alternative hypothesis. So H0 means there's no difference. P1 equals P2, equal risk. And HA means that the therapy is riskier. P1 is greater than P2. Okay. And step 2, we calculate the statistic value z. Before we calculate z, we calculate P1 hat, P2 hat, and the pooled sample proportion P hat. So the details are given here. So make sure you know which one is x1, which one is x2, which one is n1, which one is n2. And the p hat is equal to x1 plus x2 divided by n1 plus n2. Keep in mind, p hat is not equal to p1 hat plus p2 hat. Okay, keep this in mind. And z, the calculator is a little bit complicated. Make sure you get the same result as I got here. And step 3, so you calculate the p-value based on the normal distribution. Because the alternative hypothesis, HA, is P1 greater than P2. So the p-value is equal to the right tail area, which is 1 minus the left area. So the left area 0.9949 is from the normal table. Okay, keep in mind the normal table gives you the left tail area only. And because the p-value is so small in step 4, we compare the p-value with 0.05 and we reject H0 because the p-value is smaller at the level 0.05. So this means that HA is correct. In other words, the hormone replacement therapy is riskier. So next, we're going to talk about confidence interval for the difference between P1 and P2. And I'm going to show you the details. Here we carry out 95% confidence interval for P1 minus P2. Keep in mind P1 is the risk of using therapy, hormone replacement therapy. P2 is the risk of not using the therapy. We need to find the confidence interval for the difference between the two risk rates. The confidence interval is given by P1 hat minus P2 hat plus minus the normal critical value 1.96 times this part is called standard error, and the whole part here is called margin of error. Okay, and in the example we calculated P1 hat to be this number, P2 hat this number, and we plug these two numbers in the standard error formula, so we get this number. So keep in mind, double check the result. Margin of error is critical value times standard error, which is 0.0067. Finally, we calculate the difference between P1 hat and P2 hat. We get that. So we plug every piece into the formula. So 95% confidence interval is the estimate. Well, this is the difference between sample proportion plus minus margin of error, written in explicit form, and in percent it's 0.21% to 1.45%. So to interpret this confidence interval, we can say that we're 95% confident that the hormone replacement therapy is 0.21% to 1.45% riskier for healthy women who are 65 years older, more than 65 years old, and who take the therapy, okay, than those who do not. All right, hope this helps. And so after this, we're going to talk about chi-square test in chapter 21. This is the end of chapter 20.